Hello guys. Today we are going to see about the field extraction features available between Splunk and ELK. Both of these tools provide their own inbuilt mechanisms to parse through industry standard data. We are going to focus on a CSV file uh, with custom data in it, which does not fall on any of the standard categories. So we'll see how these tools handle that, and let's get started. In our setup, we have a GCP Cloud VM, and we have installed a universal forwarder which will forward data from our VM to the Splunk Cloud. And we have installed FileBeat for ELK Cloud instance. Both of these universal forwarder and FileBeat will be reading the same data, and we'll see how the other two are handling that. This is our Splunk, and this is our Kibana interface. So on my GCP Cloud VM, one is called as ELK log, the other one is called as Splunk log. So these are two files that I have created, which will forward the data to their corresponding tools. Okay, so as soon as we type data into this file, we should see the data here. So we should be seeing this data on our Kibana interface as well. Okay, so we see it here. So these are the two files which we'll take as an example today. I have also created a video on how to configure the basic things like how you can set up your own VM on the GCP cloud and then get your data forwarded to all of these instances, both of these instances. So this is my sample data, which is in form of CSV. Okay, so if you see, this one has a list of data like the host name, a random IP, random device, category, its status, manufacturer, whatever. So I have just put random data into it. I have also created a Perl file which will actually parse it, and so it is, I have put a sleep in this Perl script, so it will write the data out or the print the data out for every 1 second. So if you see the data, it is again the same data, but now it has the key and its corresponding value. So we'll start off with the Splunk. Then I put my data in. So when this data is getting written, I should also see that here. Okay. So the first issue that we see now, again, all these are individual lines on my data, but Splunk has taken this entire data as one single data line or one single data feed. So there are ways we can handle it. So we'll handle that, and again we'll focus on how to split data out, and then we'll see how we can do a basic analysis on that. On the other side, I'll also pass this data to my ELK log, and we'll have a quick look on that. So on we see the data here. Elasticsearch has taken the data in a split way. Each of this line is taken as separate line. That is good. However, you see these key value pairs will not be taken, or, not, or at least at this point have not been taken as separate items. So this entire section, including all this key value data, is now inside this message data. Okay, so there's no direct way you can do aggregation or analytical functions on these values. So we'll see how to extract these fields or extract these values and mark them as a fields now.
Okay, so now we'll focus on how to split our single event into multiple events based on new line character. There's a command called as multi-kv that can be used to perform this action. So once we run that command, now you will see that all our events are split into individual lines. And now we'll focus on how to extract these values, the values for each of these keys. So when you usually perform this multi-kv command, it usually tries to extract, Splunk usually tries to extract the corresponding fields using delimiters. So when you see here, I see few columns that were automatically added. So this specific column has both my key and my value. So I'll now try to extract these values and then create a field with my key. So the next thing that we need to do is to use a command called as regex. Regex is a command that you can use to perform a regular expression based field extraction. So I'll say field, the field that I'm going to use to pull the data out. So I'll focus on this one, column 2 now. So the field that I'm going to focus now is column 2. And the next section of this regex command is to perform the extraction. So here I'll usually it starts with the value that precedes the match that we are going to perform. So the value that precedes the match is this keyword. It says, and then after that, the next section is to define my field name. I'll just say CI name here. And now I have to specify the pattern that will follow this specific key. So the pattern that is going to follow in our case on column 2 is this. So if you see it has a domain naming. So I'll go with the easiest way. Now I see my CA name displayed here. Okay. So again, this is a field that we have extracted. The CA name is the field name that we gave, the extracted field name. This was the source field that we used. So I can do multiple regex like this to fetch values across different fields. Naming convention here. Okay, so now I see IP as my field, CA name as my field. I've extracted these two. If you want to see them in a better way, you can modify the data into columns. So if I see, uh, I don't want column 3 anymore. So now I see these values here. So likewise, I can use other fields to extract my fields.
Okay, now we come back to our Elasticsearch instance, and we already saw that our log messages were captured as individual events here. However, we saw that our individual key values were not captured as separate fields here, and it was under a field named message, and the entire content was captured inside it. So now we'll focus on how to extract these fields out. There are a couple of ways. One is called as scripted fields, which you can perform on the index pattern section on Kibana, and the other way is through the ingest pipeline on Elasticsearch. We'll see both of them. Scripted fields method is useful for extracting data on the fly on Kibana. Uh, it uses the inline memory to perform the scripting operation on the messages that we have on Kibana, and it is not advisable to use it
on a large scale data because, as we said, the data is stored on the memory until the entire process is complete. So this can lead to heap size issues as well. If the parent fields are of type text, the extraction does not work. We'll see how it works now. To access scripted fields, you need to go into the management section and go to index pattern in the Kibana and select your index. Again, as I said, there is one glitch on this. Scripted fields would not work on text fields, and the process of converting that to other type is tedious. I have my scripted field section. I'll just say, for example, I need to extract my CA name. Okay. Let me open regular expression online as well. Okay, we'll use the regex online tester to parse our data. So I have my source data here. So now I will be trying to parse this section. Okay. So I already have created a regex for that. I'll just show you if that works. Okay, so it's trying to match everything possible. I'll just remove the global. So now this specific regular expression matches this. So I'll show you how we're going to use this on our scripted field extraction. So the CA name, this is my field name onto which my data is going to be extracted. And as I said, the language is painless. And here you specify the return type of data. Okay, so now I have my script with me. I'll explain the script as well. So my value on my message is passed against this regular expression, and whatever is matching on it, the first item is getting returned back to the field. And if it is not matching anything, that field will have a return value of no match. So I can click on create field now to do that. However, it is always best to perform this operation where it gives you the preview of the results. Again, we'll see errors here. I'll explain why. So now our script extraction did not work, and we'll see the reason of it. So as we already discussed, text fields are not optimized for this operations and are disabled by default. So there are various other instructions given on modifying the value of the text message and enabling uh, the field data option on the message, but they don't work usually. So this heavily depends on the field type of our data. So let me show you the field type of my message on my discover section. So you see the field type is T, which says this is a text field, which is not fit for the scripted field extraction. So we have to go with the other way.
On the ingest pipeline method, you create a ingestion pipeline on Elasticsearch and give it a name. And then on your file beat configuration, you modify that to point to the same ingestion pipeline. So let us see how it works. Okay, so now we'll see how we can create the ingest pipeline. So we go into the DevTools. Actually, the ingest pipeline has to be enabled on Elasticsearch. So we'll on our console we'll create a put request
So it is created on our Elasticsearch. So before we do that, we'll just use this grok debugger to see how our pattern matching can work. So I'll again go back to my sample line, paste that here as the sample data. Now we'll have to define the grok pattern. I'll show you one example. Let us see how we can extract this specific data. So the first thing is like the first part is the little value of what is the starting point, and then you provide your field name. So I say CA name, and after that we'll have the regex parsing added. So I'll add my regex that we created for our scripted fields and then add it here. Yeah, so this is the correct way. So now we'll see if it can fetch the data. So from our data, it has pulled the CA name out as my field name and the corresponding value. I'll also show you one more example. So this one we see here is a regular expression. Now I'll show you how the default grok pattern matching can be used. So OV equal to is the little match of the starting point. And now I will use my grok pattern percentage. So there is a built-in grok pattern called as IP colon. This is the separation between the parsing field and our end field name. Okay, so now if I do that, so I just wanted to show you two examples here, one using our own regular expressions and also an example of using the built-in grok patterns. So now we have these patterns created. We also see that it is working. Now we have to create a ingest pipeline. Okay, so this is my pipeline. I have not put a pattern here. I have just given the ingest pipeline and my pipeline name here. So let me pull my pipeline pattern as well. I've created the pattern. Let us insert this ingest onto Elasticsearch. So let us go back to our compute instance and try to create that pipeline on our file beat config. Okay, now we'll edit our file beat config. So we'll insert the pipeline statement here. So I'll just say pipeline and then my pipeline name, which is my grk feed. Okay, I'll save it and then I'll quickly verify if this config is valid. Okay, so after all its testing, it says the config is okay. So let me restart my file beat. Service file beat restart. Okay, so now we'll see if we are able to see our fields here. I have my CA name displayed here. Okay, so I'll just remove my message field on the display so we can see things better. CA IP, country, CA model. Okay, so since we now are able to see all these fields extracted out of the raw data, have uh, we can now have aggregation functions run against these fields, and now we'll have better visualizations created out of these. We'll see those on our next video on how to handle this data and create visualizations in both Splunk and
Elasticsearch.